Hello class. Before we make this video about chapter 8, just checking in. How you guys doing? You guys surviving? You able to handle this online stuff, or are you slowly going crazy? We haven't been to school in approximately this long. I didn't have any facial hair when we left for March break, but I'm growing it out. Why not? Never really had like a really good beard before. I don't know how long I'm gonna get it, but who knows? We'll see. Chapter 8. So this is comparing two variable data. This is gonna tie back way back into grade 9, where you guys, probably a bunch of you had Miss Mariani, and you're learning about scatter plots. So there's a few things about scatter plots. This is the one that has a bunch of dots on it. We always place our independent variable on the x-axis. Now, if you're given any sort of table, this was usually either the first column or the top row of the table, depending on how the table's laid out. So the textbook should continue to follow that pattern, but when you guys do your research, you'll have to be careful and just double check. That means that we have our dependent variable on our y-axis here, okay? So that was like our first kind of thing on this checklist that I want to address. Next, for our line of best fit. Okay, so that's what I'm estimating our line of best fit to be. In grade 9, that's all we did. You would sketch on a line of best fit that would try to adhere to a couple principles, a couple rules. So one of our rules is that we tried to hit as many points as possible. We try to have roughly the same number of points on either side. It's got to follow our trend. So that's kind of the pattern of the data. So we could have a curve of best fit. Right now we're looking at a line of best fit because we've got more of a linear relationship here. And also, your line of best fit should extend past your data. Okay, so that was kind of our line of best fit. So those are some of the rules that we had. We still are going to follow these, but for our final project, where we're headed, we're not going to draw these by hand. We're going to use some online calculators to accurately draw these, because when we sketch something on, it's really kind of, I think it's probably around here, kind of guess. You need software to accurately calculate the exact slope of where that line should be. So there's a calculation that kind of measures all of these distances and tries to have it sandwiched perfectly in the middle so that there's an equal distance from all of the points to the line. Okay, so we won't be getting into those calculations. We're going to be using some software to do that for us. So basically what that's called is linear regression. Okay, so we're going to be using some online linear regression calculators that will draw the line for us after we insert a table of values. Okay, so we'll enter in all of our x and y values. It will create the line of best fit for us. It's going to be using that good old y equals mx plus b to do so. And we're going to end up getting an R value called a correlation coefficient. Okay, so before I get into that, I want to talk about interpolation and extrapolation. So again, this was something from way back in grade 9. And anything that is between your first and last point, anything in this range, this was called interpolation. Now, interpolation was used if we ever had to make some sort of estimate within our first and last data points. And these were usually fairly reliable guesses because kind of you're right in the middle of the action. So if for some reason, let's say this here is 10. When our independent variable was 10, we wanted to know what y was. We could say that this is 5. These are kind of arbitrary numbers, but we would use our line of best fit to make a guess for our set of data. Okay, so that was an interpolation. If we were ever making a guess outside, so on either side, so before our data or after the data, that was called extrapolation. And these are less reliable, they're less accurate because, you know what, over time, things change dramatically, especially as we get further away from our data points. So these are less reliable, but occasionally we'll use those. Okay, so that was interpolation.